You were probably taught that a function looks something like this. But that isn't what a function fundamentally is. A function is much easier and simpler to understand, and it doesn't have to involve numbers. We can make a function of anything. It can even be a restaurant order. Hello sir, may I take your order? Oh hello, is your ordering process much like a function? Excuse me? I don't... We can make useful functions, pointless functions, and absolutely absurd functions. But then, what is a function? What is f of x? And why did we draw vertical lines through graphs in school? To answer those questions, we're going to have to define the function of this video. Yeah. Let's stop thinking about these weird symbols. Let's think of a function as a process. Something goes in, a rule is applied, and then something comes out. We can put in a person, and out comes their date of birth. We can put in a date, and out comes the day of the week the date falls in. And yes, just like in school, we can put in a number, and out comes another number. The function is the rule that's being applied, and that rule can be anything. And I really do mean anything. Aha, so it can be a menu order. I'm sorry sir, are you going to order something? It can be a menu order, but let's take a step back. But don't think the rule even has to make sense. It doesn't even have to be useful. We can define a function where you put in any object and out comes Spider-Man. Say a chair, Spider-Man. Camera, Spider-Man. What about if we put in Spider-Man? Still Spider-Man. See, that is still technically a function. So let's stop thinking about functions as these restrictive problems that we're only given in a classroom. Think of them as a game of Monopoly or even a Lego. Yes, there are some rules you have to follow, but really, there is a lot of freedom for you to play with. But if we really have that much freedom, what stops me from putting absolutely anything into the function? Perhaps I'm making functions sound a bit too free. So let's see what happens if we take our birthday function and try to put in a carpet. It doesn't work because a carpet doesn't have a date of birth. So the date of birth function only works for people. So the set of things that a function can take in is called the function's domain. And the set where the outputs come from is called the codomain. But I don't understand, sir. Why can't I order an air conditioner? Because we don't serve air conditioners, sir. I see. So in other words, air conditioners are not part of your domain. Exactly. And the codomain would be the actual food that's getting prepared in the kitchen. If that helps you understand the menu, can I take your order? Yes, that's the codomain. I think you're getting it now. There is, however, one crucial restriction. A person can only have one birthday. And yes, it may be that two different people have the same birthday. But one person cannot give you two different birthdays. And this is where schools teach us about many-to-one or one-to-many. Let's put all that aside. The key idea is we put in something, we get exactly one thing back. If not, it's not a function. And that's exactly what the vertical line test is checking. If the line touches the graph in two or more places, it's not a function. And now we can finally answer the question we asked at the beginning. What is f and what is f of x? So let's think of the restaurant order again. You make an order, the restaurant processes your order, and then at the end of it, you get a meal. The restaurant's process is the function. Your order is the input, and the meal on your table is the final output. So we can call the ordering process f, and we can call your order x, the input, and the output is f of x. So f and f of x are not the same thing. I see. I hope you're taking all of this on board. Yes, listen, my manager's getting really annoyed. We're going to have to call security and we're going to have to ask you to leave. But I haven't finished my food. We'll box it up for you. But what if I want my food delivered? Now that we know the difference between f and f of x, we can ask a much more interesting question. What can we do with f itself? Well, with things in maths, we can add them, we can times them, we can multiply them, we can subtract them. But what can we do with a function like f? We can connect it to another function. So let's think of the restaurant order again. We have your order, the restaurant makes the order, it gives you a meal, and then the delivery driver takes the meal and delivers it to your door. So that's two separate processes, but in the whole of it, it's become one big function. So this is what we call a composite function. And this is the notation. Reading it, you start from the inside and move your way outside. The notation may seem difficult, but it's no more complicated than a restaurant taking your order and then the delivery driver delivering your order. But when we add and multiply, it doesn't matter which way round we do it. But if we compose the functions the other way round, do we get the same result? A driver can't deliver your meal before the restaurant has prepared your order. Your order, sir? Where's my food? The restaurant hasn't made it yet. So sometimes reversing the order makes absolutely no sense. How does this lead us back to the numerical functions that we were taught in school? Ultimately, everything I've said up to this point is fundamentally what the functions in school were doing. So let's say we have the function of squaring the input, or as we may have seen, f of x equals x squared. We can define this function on the set of real numbers, and the outputs will be on real numbers. We may even have some functions that are only defined on the rational numbers, or perhaps only the integers. For example, we may have a function where you put in an integer and we get the remainder after you divide by 7. That might sound oddly specific, but we'll come back to that. And to be fair to the schools, the functions were not just invented for classrooms. They help us describe the real world. For example, we might have a function of time which shows us the position of a planet at that time. The idea hasn't changed. We give the function an input, a rule is applied, and the function gives us an output. The difference is, functions describing reality can become extraordinarily complicated. Not all of reality wants to behave like a nice quadratic equation. So that is why the schools start us off with equations like 2x plus 1 and ax squared plus bx plus c. They're not the limits of what a function can do. They are manageable examples that teach us the language of reality. And then you may think of these functions as the position of an asteroid and a planet, and see that if they intersect at some point, we may have just predicted a collision. Or perhaps these graphs never touch each other, so we know we're safe. Of course, it's not that simple, but it genuinely is the underlying mechanism that helps us predict the exact moment of a solar eclipse or an asteroid impact. But this video is not about astronomy. We've discussed what functions are, how they can connect together, and why numerical functions matter. So these are all the little details you may miss behind the school equations. A function is a rule that we define. The symbols themselves aren't the idea. They're just the way we write the idea down. So the next time you see f of x, don't think of a restrictive problem. Think of it as a rule that you are free to build. And remember the function I gave near the beginning of the video where you put in a date and out comes the day of the week? You can actually do that in your head within seconds, but it requires modular arithmetic. So if you want to see a function doing something genuinely surprising, you can watch that next. Thank you for watching, people. If you'd really like to know how to calculate the exact day of the week for any given date, let me know in the comments, because we can show you beyond the method online how to do it within a matter of seconds, the shortcuts, the tips and tricks that makes it all very intuitive. So if you'd really like that, I'm going to make a PDF booklet showing everything step by step, and I'll give it to you guys for free. If you enjoyed this video, please like and subscribe, and I'll see you in the next one.